Alright, so here is actually a problem that we've done before, and I'm going to work this one out in the video, and then you're going to work out number 6 on your own. And what I'm going to have you do actually is go back and recheck the answer to your Google Docs for homework tonight. And so let's go ahead and get started. First, we are pulling a horizontal desk, and it's being pulled with this force F that goes up at an angle of 30 degrees. We have the weight of the desk going downwards. We have the static friction force acting against it. And now what we want to do is we want to split this into components. So we're going to have Fx and Fy. And let me just kind of stop for a second. Let me back up here. So first, what have we done? So we have actually gone ahead and drawn a correct free body diagram for the mass. Now it says find the x and y components of any forces pointing at an angle. Well, that's this F right here. We actually need to find its x and its y components. So let's do that now. In fact, that's what they ask us to do in part C, so I'll just do that work down here. So Fx is going to be 200 times the cosine of 30, and Fy is going to be 200 times the sine of 30. And I'm going to go ahead and plug both those numbers in. I'll get 173 newtons for the Fx and 100 newtons for Fy. And that's what we use in our equation. This is Fx and that's Fy. So now I can use this fact or this free body diagram to do step 3, which is actually right here, and step 4. And step 5 that they want us to do is actually down here at the bottom. So they say, what next? Balance the forces in the x direction. Let's go ahead and do that. So I have Fx. Once I've split this thing into components, I ignore it. I only use the x part. So Fx, going to the right, that balances out friction, and those two cancel. Some of you might be tempted to write it this way, and that's totally fine. And then in the y direction, again, we're going to have forces. You know what? There's a force that I left out. I left out the normal force, so we got to put that in there. So we have the normal force and Fy acting upwards, and we have the weight pointing downwards. Again, I'm reading these off the picture. I have this foot going up, that force going up, that force going down in the y. And so now what I'm going to do is I'm going to go ahead and solve the problem. So let's determine the value of the friction force. Well, what we've determined in part 3 is friction equals the horizontal component of the force, which is 173 newtons. Great. Now let's go ahead and get the normal force. So we have the normal pointing up. We have the y, and a lot of people at this point just want to jump in and say normal equals the weight. I just want to say that in this problem, normal is not equal to the weight. Please remember that. So we have the normal pointing up. We have Fy pointing up, which is 100 newtons. And we have the weight pointing down, which is going to be 50 times 9.8. And so when we solve for the normal force, we end up getting 390 newtons worth of force. Now your job in the next problem is to go ahead and solve this problem, but now we're pushing down on the desk. So your free body diagram actually ends up changing, and I'm just going to get you started on that. Your free body diagram should look like this. And I will give you a hint. You're going to end up getting the friction force is the same, and you're going to get a normal force equal to 590 newtons. So that's what you're going to need to kind of do. And you should do that on your worksheets right now. And when you're done with those worksheets, as the instructor or the sub has told you, you need to go ahead and work on the problems from, let me find the packet. You want to work on the problems from this packet right here.